Okay, I again recorded and I again realized that I again did not record an audio. I don't know what's happening nowadays to me. But yeah, let's start off. This is Trapping Rainwater 2. Now, again, if you haven't watched Trapping Rainwater 1, I will highly recommend go and watch it, link in description, because it will help you an idea how to build a follow-up. You are given a m cross n integer matrix height map representing the height of each unit cell in a 2D elevation map. Imagine that you are given a 3D diagram. Now, if you look at this 3D diagram from the very top view, you will see a grid, or a matrix that will represent, that matrix will actually represent the corresponding height of each cell. For example, this represents the height of 2. This represents the height of 3. This, which is kind of hidden background, will have some height. I don't know what. So that top view of heights is given to you as an input. You have to figure out what is the volume of water which you can store right after raining. Now obviously, as we have already solved trapping rainwater 1, so it will very much intuitive to us that for a specific cell I will try to apply trapping rainwater in its row and trapping rainwater in its column, and how much water I can trap in, let's say, column it is C, in row it is, let's say, R. I will take minimum of that much water I can trap, and you will be surprised to know that it actually works. Because if I have a building of height 3, again this is, I have represented the exact same row above. So if I have a building of height 3, height 2, height 1, height 3, sorry, height 2, and then height 4, you will easily see that I can trap to 1 unit of water, because apart from it, it will start overflowing from the left side. And thus, if I do the same thing, if I do the same thing for this specific column, I will again realize, okay, 4, 2, and 3. 4, then 2, then 3. Again, I can trap one unit of water, else it will flow from the right side. Thus, for 2, I can trap 1 unit of water. 1 unit of water. Same way for 1, if I look like this and like this, I can trap 2 units of water. Same way for this 2, I can trap 1 unit of water. Thus ultimately I will be able to trap 4 units of water, and it's actually the answer. Is it true? You might argue yes, but I just change very one basic condition. Instead of this being a 3, I change it to 1. Now if I ask you again, for this 2, row is same, column is same, tell me how much water you can trap at this location 2. You might argue again, 1. No, because as soon as you put some water here, firstly it is less, so it will flow on the right side. Okay. Earlier this was a 3, this was a 3, so it was holding up the water, but now it will flow from here, and thus it will flow outside. Did you realize what happened? You realize that the amount of water which is being stored at a specific cell is not only determined by its row or columns, it's actually determined by any cell of this matrix. Because it might happen that water might flow here, here, then maybe here, then, then maybe here, then here, then here, and then maybe out. So, for one cell to figure out if the water will be there or not, I might have to figure out its neighbors. On top of it, their neighbors. On top of it, their neighbors. That is kind of exploring exponential cells, which obviously will give us TLE. Then what to do? Just figure out what actually was the issue when you're exploring all the cells. Ultimately, if the water will flow out, it will flow out from one of these edge cells, or I should say corner cells. So I should only and only worry about these corner cells, and this is what we will also do, that we will only and only worry about these corner cells, which means these are the corner cells which are the culprit, which will actually be responsible for flowing of the water. Okay, so we realize we will actually start exploring from corner cells, and when I say explore, I mean obviously explore the corresponding neighbors. For him, I'll explore his neighbors, and which means that I am exploring neighbors. And what is the best algorithm to explore neighbors? That is simply BFS. Okay, but now the second task is that you will start exploring from the corner edges, corner cells, which is the corresponding corner edges, and then you will use BFS. It's true. But what if your ultimate aim was to get the amount of water stored? How will you get that? It's simple, because if you have one unit of water stored, like a wall of one here, obviously you cannot store any water on the edges. That's obviously prohibited. Now, if I ask you, this is his neighbor, how much water you can store here? Obviously, only one, because anything more than one will actually end up overflowing. But if this neighbor cell would have been a 3, again, forget about these corner cells right now. If the neighbor cell would have been a 3, you would end up storing 2 unit of water here. You would end up storing 2 unit of water here, right? If this neighbor cell would have been 1, you cannot store any water here. So, with this observation which I showed you just now, you have to figure out first thing, how much water to store, which means that impact in the answer. Impact in the answer. Second thing is that what can I propagate? Second thing is, what can I propagate? What do you mean by propagate? Propagate means that if I have a wall of size 3, again, I have asked you to forget about its neighbors for now. If I have a wall of size 3, I can simply tell my neighbor that, bro, don't worry, and tell your neighbors that you have a backup wall of size 3, which means this 3 will tell his neighbor that, "Okay, bro, I am backing you up," and tell your neighbors that you can store water up till size 3. So this is how the propagation will happen. Now you might ask that, Aryan, what if this lower wall will say as a backup? No, he cannot say anything as a backup, because obviously when he will say, bro, I have a backup of size 1 for you, he will say, bro, I don't want your backup because I already have a higher wall size than you. So we realize that a higher wall will tell a lower wall, okay, bro, no worries. You can propagate to your neighbors that you are backed up by a higher wall size. And lower wall size is technically cannot do anything. So yeah, he will be as is. And same way for equal wall size also, he cannot do technically anything. But thus you realize, okay, we need to handle a kind of propagation. Propagation will simply say that take maximum wall, or I should say maximum wall height or size. So this is another observation which we figure out. Okay, with all these observations, there's one last observation, that you said that you will start exploring from the corner cells. There are all these cells as the corner cells. The question is, which one will you start exploring from? Now, you might argue that any cell. I will say no, because to actually drain the water out, or the capability to drain the water out, is with the lowest height cell. Thus, I have to start exploring from the lowest height cell first. Start exploring from lowest height cell. Let's change the color. Cell first. What it means is that you have to use a data structure which can give you a lowest height cell as fast as possible. Lowest height cell. Now, obviously, which means that I have to maintain the height, and I also have to maintain the row and column. Why row and column? Because obviously I have to explore neighbors. So to explore neighbors, I need to know the current cell. And height, because the data structure will be sorted by this specific height. What are the data structures which we have? Obviously, we have priority queue, we have map, we have set. Again, as it is a very plain and straightforward, so I only need to sort by height, that I can simply use a min heap or a priority queue. So I'll simply use a min heap. Now it is very straightforward. I can simply use a min heap. I can start exploring from the corner cells. I will explore the cells as I figure out any height which is lesser than me. Like, let's say if I am here and if I explore any height which is lesser than me, and it is not visited, then I can simply get how much water to store and increment my result or the answer. And I will also propagate my height, which is the maximum height I can propagate to its neighbors. Let's do a very quick dry run with all the knowledge which we have gathered so far. So in the very beginning, we realized, okay, let's change it back. We realized that we will start off by exploring its neighbors. So I'll simply, when I put a dash, I mean they are visited, and my BFS will not visit that again. And when I put a cross, I mean that these elements are now out of the priority queue. Anything which is visited will actually be in the priority queue, and anything cross, which means it I have explored this thing and it is no more in the priority queue. So I told you in the very beginning, I will explore the smallest cell. So when I explore one, its neighbors are 4 and 3, which are already visited. So I will not put them in the priority queue. Okay, which means I will not visit them. Next smallest cell is 1. If it is 1, I will firstly check. Okay, neighbors are already visited, no worries. But 3 is there, which means that I am 1, he is 3, he is a higher value than me. So he, I cannot store any water here. I cannot store any water here. That is forbidden. If it is forbidden, which means that now what? Again, what if it would have been a 0? Then in that case, I can store 1 unit of water here and I would have incremented my answer. But here it is 3. I cannot do anything. So I will simply visit this cell. Again, I simply visited the cell. When I said dash, I visited it. Okay, and when I say visited, I mean push it in the priority queue also. Okay, now let's proceed forward. Next smaller cell. Next small cell is again a 1. Okay, visited. Again, both the neighbors are already visited, so no worries. Okay, next smallest cell come as 2. Visited. You saw? Okay, visited it. 3 and 4 already visited, no worries. Next smaller cell 2. 3, this 3 and this 3 all are visited. So nothing to change here. But you might say, Aryan, it is actually pretty good, right? Will I propagate the backup? I said no. Obviously, you might say propagate the backup, but when one will have propagated his backup would have, or I mean that his propagation would have been rejected straight away because I am having a higher value. So I am propagating the maximum of myself. Okay, where it is gone? Myself and my neighbor. That is my neighbor, what he will propagate. Then this two already, these two are already, at cells, so no worries. Now comes the next part, which is 3. For 3, firstly, I will, it is this thing I will pick up from the priority queue. These are already visited. This is not. If this is not, I will simply visit it. Then this 3 will say, okay bro, you are my neighbor, you came up, which means that, again, I was the first person, or maybe any person in your surrounding, and you are my neighbor which is not yet visited, which means any of your neighbor has not visited you yet, which ultimately means that I am your smallest neighbor. So 3 is my 3 is your smallest neighbor so far, which means that this 3 will help me add a water in myself. So this will say the water will increase by the corresponding height, which is the current height which I have. As you can see, current height which I have, which is right now 3 in this case, and the neighbor height is, let's say, neighbor height, which is 2. And thus I will simply add a 1 in my water count. I'll simply add a 1 in my water count. Now, if 1 is added, what I will propagate now? Obviously, I will start propagating a 3. As I told you, that 3 is higher, it is lower, it will start propagating a 3. So, technically, this is now visited, but the value is now a 3, not a 2 anymore. Okay. Now, again, when I say visited, I mean I have pushed in the priority queue. Next, let's visit a next cell. I can visit this also again, but okay, let's try visiting another cell. Let's say if I visit this cell, visited, no worries. If I visit, let's say, this cell, okay, visited, this is not visited. If this is not visited, he is his neighbor, not visited. So obviously, I can store a water of how much? 3 minus 1. I can store a 3 minus 1, which is a water 2 I can store. And now, before visiting it, make sure that propagate the length. Again, propagate the length or height. That, bro, you now know I can put a 3. But just before that, one thing, the smaller value would have been here, but but it is so far not yet visited. So when this 3 is would have been visited, okay, first let's visit like this 3. Now you are done. Now you added a water. Now you will visit, let's say, another 3. Let's say this. Okay, firstly visit this specific thing. Now you visit another 3, this one. His neighbor is 2. Add a 3 minus 2, which is add a 1. And then make sure you propagate the value, higher value. Make sure this is visited and this is gone. Next value is 3. This 3, it is visited because his all neighbors are visited. This all neighbors are visited. Then comes this value. When visiting it, his all neighbors are also visited, so no worries. When visiting this, his all neighbors are also visited, no worries. When visiting this, his all neighbors are also visited, no worries. When visiting this, his all neighbors are also visited, no worries. Then lastly, 4 is there, but his all neighbors are also visited, and 4 also all visited, all neighbors are also visited, and thus the answer is 4. Cool. Let's see the code again. It's exactly very similar. I will show you with the help of diagram also parallelly. Let's say it is 3. Let me just quickly copy this entire thing and put it down below for you so that I can explain you with the help of code also, although you should write the code by yourself first, but still let's see the help with the help of code also. Firstly, you will see that I maintained a cell. Again, a bit of good practice when the code becomes complicated. Now a cell will have a height, row and column. So although not required to have private and public methods in actual interview, you don't have that much time. So yeah, don't do this in an interview. Just address things by dot h dot r dot c and not by get height, get row, get column. Now comes the fun part. I have a visited vector which will tell me what thing I visited, and the thing which is the priority queue. Priority queue is nothing but here the main heap. Min heap sorted on the basis of its height. Smaller the height, that element will be the top of the min heap. Then I pushed up all the elements which are these. As you can see, I go to all the rows. If I go to all the rows, I will push up these elements. Okay, I should not change the color. I will push up these rows in my visited, and also in my priority queue I will put up all these elements, because I told you I will start off traversal from the corner elements. So I put them in the priority queue and I also visited them. Same way I will do it for the columns. For all these, I will put them in the priority queue and also in my visited. Now you might say, Aryan, these are put up twice in the priority queue. Yes, technically they are put up, but this will not impact the answer because his neighbors are already visited. So these corner elements are technically, you might put up n number of times, still they will not impact your answer because they are, never gonna have any neighbor which they can put up. So yeah, you can simply ignore them also. Now comes the fun part. I will simply apply a BFS while my priority is not empty. Get the current cell. Get me all the 4 directions. Which this is the new row, new column. I will check if it is a valid cell which I'm going to, and also it is not visited. Only in that condition, get me the extra water I can have. And as I mentioned previously also, that if I am at a specific cell, if my value is a 3, my neighbor value is less. My value is the current height, and the neighbor height, which is the height of my neighbor r comma c, if it is less, then simply I can add a height difference 3 minus 1, which is 2. If it is equal, then okay, 3 minus 3, 0. If it is more, 5, then obviously I cannot store any water in that scenario. This thing will become negative, so I should rather store a 0 as an answer in my water. The impact of how much water I can store. And when water impact or water addition done, then go on and try to push the actual maximum height. This is what I was calling as propagation. What I mean by that is, if it is 1, so for your neighbor r comma c, you are about to put element in the priority queue, but just tell him, bro, I am backing you up. 3 will tell him that I am backing you up, which means I will store the maximum value of 3 and 1. For this r comma c, I will store the maximum of 3 because 3 will now back him up. So this is I'm storing. What if this would have been 3? Okay, still the maximum would have been 3. What if this would have been 5? Okay, still it would have been 5. So this will simply say that a higher value has backed you up. So make sure that you incorporate that in your priority queue. And make sure that you visit that cell because you don't want to visit things again and again. Now, because you are visiting each and every cell, the time will be O of m plus n, sorry, O of m into n. And considering you might end up putting, in worst case, all these elements in your corresponding priority queue, thus log of O of mn, you can say, although it will be much lesser than that, but still. And space, obviously in this case you are making a visit, you are making priority queue, space will also be O of m into n. And that's your time and space complexity. Cool, I hope you guys got it. Again, it is not that tricky, but you might get confused on applying the trapping rainwater again. But if you just make one edge case, you will easily figure out that what's the strategy to solve this problem. Bye bye, take care.